Hello everyone. Today we will discuss what happens when an electric dipole is kept in electric field. Here we will consider two cases. First case, when the field is uniform, and second case, when the field is non-uniform. So let us consider first case. In first case, we will keep an electric dipole in uniform electric field, and we will find an expression for torque acting on it. So our first topic today is expression for torque acting on dipole kept in uniform electric field. I have underlined the keywords here. Uniform electric field. All of you know meaning of this. Uniform electric field means the field whose strength is same at every point and direction is also same. And uniform electric field we are represented by equally spaced parallel lines. So in this diagram, green color I have used to represent uniform electric field. Equally spaced parallel lines we have shown here, and direction of electric field is from this side to this side. So electric field is pointing in this direction. And what is direction of electric field? Direction of electric field is the direction in which the positive charge will experience the force. So I hope this term is clear to you, uniform electric field. Next is dipole. A system of two equal and opposite charges separated by a small distance is known as dipole. So here this red line is representing the position of dipole. This is having one charge minus q, other charge plus q, with the length of the dipole 2a. And this dipole is making an angle theta with the direction of applied electric field. So angle between P, what is P? Direction of dipole moment, that is from negative to positive charge. So angle between P and E, this angle is going to be theta. And what is torque? Turning effect of force will be known as torque. So for this we have considered this dipole present in uniform electric field with the dipole length 2a. Now we will see what will happen when we have kept this dipole in uniform electric field. Dipole consists of two charges, plus q and minus q. And strength of electric field we have represented by E. So when this charge will be kept in this electric field, it will experience a force. And electric field intensity formula is force divided by charge. So what will be force acting on this positive charge? Force acting on this positive charge will be charge multiplied by electric field intensity. So it will be Q into E. And direction of this force and direction of electric field intensity both will be same. So these two directions will be pointing in the same direction. And what is the force experienced by this negative charge? Magnitude wise force will be same, but direction wise this force will be opposite to the direction of applied electric field, because direction of electric field is the direction in which the positive charge will experience the force, and this is negative charge. So this will experience a force in a direction opposite to the direction of applied electric field. So this is direction of force experienced, this side. This is direction of applied electric field. Both are opposite to each other. Now, these two forces are equal but opposite. So for linear motion, net force coming on the dipole will come out to be 0. It means acceleration, linear acceleration produced will come out to be 0. But these two forces are acting at different points of the dipole and they will produce the torque. It means they will make this dipole to rotate. This electric field, how rotation will take place? Let us consider this is the position of dipole. So positive charge will experience a force in the direction of electric field. So rotation of the dipole will be in this direction. It will be in clockwise direction. This charge will experience a force in upper direction. This charge will experience a force in Downward direction means rotational effect will take place in clockwise direction. So magnitude of torque that is acting, we know its formula is either force multiplied by perpendicular distance between line of action of force or between these two anti-parallel forces, because one force is acting in this direction, other force is acting in this direction. So this is perpendicular distance between their line of action. And what is the magnitude of force? Magnitude of force is Q into E. And what is perpendicular distance? Perpendicular distance in this diagram you see, this is AC. So in triangle ACB, we have to find the value of AC. So we can use a trigonometry sin theta, that will be equal to perpendicular upon hypotenuse. So sin theta will be equal to AC upon AB. AB will be equal to 2A. So AC will be 2A sin theta. So when we will put value here, we are left with magnitude of torque is equal to Q into E into 2A sin theta. Now you know Q multiplied by 2A. Q multiplied by 2A. This is known as dipole moment. So Q into 2A, this we will replace by P. E as it is, sin theta as it is. This is magnitude of torque. And if you want to represent it in vector form, then in vector form this torque will be P cross E. We cannot write it to be E cross P because vector product is going to be anti-commutative. The direction in which the dipole is going to rotate, we will curl the finger of our right hand in that direction. Now this dipole is experiencing rotation in which direction? This is dipole. It is experiencing rotation in this direction. So we will keep our right hand. I will curl the finger of my right hand in the same direction, clockwise direction. Where is thumb pointing? Thumb is pointing perpendicular to this paper and in inward direction. So what will be direction of torque? Direction of torque will be perpendicular to plane of paper and pointing in inward direction. So torque is a vector quantity and sometimes it is asked here name the two pairs which are perpendicular to each other. So torque is perpendicular to P and torque is perpendicular to E. This question was asked in board exam also. So here I have explained how to find the direction of torque. Curl the fingers of your right hand in clockwise direction in this case. Then thumb will give the direction of torque. In numerical, if theta is given, then you will use this formula to find torque. And if theta is not given, P and E are given in vector form, then you will use this formula to find the value of torque. Now we will consider few more cases in uniform electric field only. Cases will be if your dipole is kept parallel to the direction of electric field. Parallel to the direction of electric field means this is the direction in which positive charge will experience force. Dipole moment direction is from negative to positive. So both are kept parallel to each other. Theta will be 0. So when we will put value of theta is equal to 0 in expression of torque, torque will come out to be 0. So no torque will act in this case. And when no torque is acting, this state is said to be state of equilibrium. And this state is stable. Stable, unstable, I will discuss with you when I will consider one or two cases more. So here torque acting is going to be 0. Let us consider second case when we have rotated this dipole by an angle of 90 degree like this. So this will be the situation. When you will put 90 degree angle, sin 90 is going to be 1. So torque experienced is going to be maximum, that is PE. From here we can give definition of dipole moment as well. If E is 1, then dipole moment will be equal to torque. So we can define dipole moment is equal to torque experienced by a dipole when it is kept perpendicular to the direction of electric field, and the strength of electric field we have considered unity. In this case, it is going to experience some net torque. So this case is not a case of equilibrium. Equilibrium case, first case we have done when theta is equal to 0, torque is 0. Let us consider this dipole is further given a rotation of 90 degree like this. So third case, theta is going to be 180 degree. Electric field and dipole moment both are in opposite direction. Sine 180 degree is 0, torque is 0. So here also we have state of equilibrium, but this is unstable. This is stable. How we will consider that this is stable and this is unstable? Stable means dipole is slightly displaced in this case. And if it is able to regain its original position, then this will be known as stable equilibrium. For example, if I will consider this case, I have displaced it and again it comes back to its original position. It means this is stable equilibrium. And if in place of this, I will consider this, I have applied the same force, but it is unable to regain its original position, means this is the case of unstable and previous one was the case of stable. In this case, if you will shift the dipole from this position to this position, let us consider, then electric field will make positive charge to turn this side and negative charge this side. So it will come in new position. It will not be able to regain its original position. So this equilibrium is unstable. This equilibrium is stable. This is a very important question of 1 mark from examination point of view. Now when theta is equal to 270 degree, we have further given rotation to it by an angle of 90 degree. So this is the angle 270 between P and E. In this case, sine 270 will be -1. So torque will be experienced. Direction of torque in this case and direction of torque in this case both will be opposite. And this case is also not a case of equilibrium because torque is experienced. Again, if we are going to have 360 and 0 are same. Torque experienced will be 0 and case will be of stable equilibrium. Second case that we have to discuss is what happens when the dipole is kept in non-uniform electric field. Non-uniform electric field means whose strength is going to change with the change in distance. You can consider the field produced by a point charge. With the change in distance, the value of electric field is changing. So this is the electric field we have represented a direction. And when I am moving from this direction to this direction, the magnitude of electric field is also increasing. So direction of increasing field, this means movement from this side to this side, means we are moving from lower electric field region to higher electric field region. And in this case, we have kept a dipole parallel to the direction of increasing value of electric field. This is dipole with minus q plus q. Direction of dipole moment will be from negative to positive. So in this presence of field, this charge will experience a force, this charge will experience a force. But if we will compare with previous case, here forces will not be same. It will experience more force. It will experience less force. Because what is force? Force is charge multiplied by value of electric field intensity at that point. At this point, value of electric field is more. So force experienced will be more. Here, value of electric field intensity is less. So force experienced will be less. And both these forces are acting in opposite direction. Who will dominate now? This direction force will dominate. I have shown it by bigger arrow also. This force is more than this. Magnitude of force experienced by positive charge is greater than magnitude of force experienced by negative charge. So what is the direction of net force? Direction of net force will be direction of this force. So net force will be acting in this direction. Again, board question, important question. If we will consider the case that dipole moment and electric field both are anti-parallel to each other. So this is direction of increasing value of electric field. Dipole we have reversed as compared to this case. This side negative, this side positive. Now who will experience more force here? Negative charge will experience more force because here the value of electric field strength is more. Here value of electric field strength is less. And what is force? Force is charge multiplied by value of electric field strength. So this will experience force in this direction, and positive charge will experience a force in the direction of electric field. This force is less, this force is more. So what is net direction of force acting? Net direction will be in this direction. So it will be pointing in this direction. When we are going to consider this case, these two cases, then we have seen that there is net force acting. Net force is not zero, but torque in these two cases is 0 because theta is 0 or theta is 180 degree. Torque depends on location. It may be 0, it may not be 0. It depends on which location you have kept your dipole with respect to electric field. So try various questions related to this. That's all.